Hi, this is a look at another control system I made. A few days ago I showed you a temperature feedback control system, but this is more of an airflow control system. It's got a fan right here, a four-wire computer fan with pulse width modulation input, and then on the other side here we've got a thin aluminum sheet metal spatula, piece of wood, and a magnet. And mounted right there on the plexiglass is a Hall effect sensor. And then I've got all that stuff going to my little analog feedback circuit here with a 741 op amp just acting as a voltage converter, and then a 555 timer as the PWM. And there's the batteries that I'm using, plus the 24 volt power supply here, which goes to a 12 volt voltage regulator for the fan. But basically, let me show you how it works here. I can put my fan in there, put my hand in there to block the airflow, and you can see it speeds up because it's trying to keep the paddle in the same place. And if I move it back, the fan slows down. Or if I force the magnet closer to the Hall effect sensor, you can hear the fan speeding up. So it's a nice little control system. It's actually intended to be hooked up to a National Instruments 6000 something series module, I/O module. So that'll be the main feedback mechanism, but I just wanted to hook it up to a little analog circuit here just to make sure it works before I give it to the teacher who will be using this for his class. And here's a quick look at the PWM signal and the voltage output from the Hall effect sensor. You can see if I move the paddle away from the Hall effect, then the minimum voltage is about 2.6, and we get a minimum amount of pulse of duty cycle on the modulation. And then when I move it closer, the voltage output from the Hall effect goes up to a maximum of 4.3, and that maximizes the duty cycle. Thanks for watching.